Good evening. Good evening. Mm. We will wait for a minute. Good evening. Is my screen visible? One minute. So can we start now? So can anyone please tell me the bullet points? What is waste? And what are the types of wastes? So yesterday we discussed about the definition of waste, correct? So what is waste? Yes. Yes, the activity which consume resources and material, but customer is not willing to pay. Okay, the customer is not downtime plus one, it is team good plus one or the word downtime. So yes, activity which consume the resources, which consumes the material, but customer is not willing to pay for it. That is called as waste. Yesterday, yes, we also discussed that yes, material, machine and man, because material is contributing there about 60 to 65%, machine is 25% and man is 10%. So ideally, man, machine and material should not wait. But if we want to give the priority, then we should prioritize the material, because material should be treated as a prime minister, because it is very, very important. Clear? Then we discussed about the defects, overproduction, waiting, non-utilization of human talent. Yes, you can also say team would. Some people are saying team woods, and yes stands for skill. So team woods, downtime, it is okay. But team wood is the original 7 West. Okay. Then we also discussed non-utilization of employees, transportation, as well as the motion. We recap about the 3G approach, correct, and the UNO circle. UNO circle is the approach that you will capture the facts because you are on Gemba, and also we discuss Gemba never lies. Okay. Yes, General Motors and Toyota, that example. And that is POUS, point of use storage. Particularly, if you would like to work on the motion waste, so that concept is very, very important, point of use storage. Okay. So we will discuss about now inventory and excess processing. Okay, and you need to remember the word downtime. Clear? So this is defect. This is summary slide I made. Defect means the effort involved in sorting, reworking, or correcting the defect occurred. Overproduction means production more than needed or before it is needed. More, sooner, or faster. That is also overproduction. So more, sooner, or faster. And as per Taichi Uno, overproduction is the biggest waste at all because it consumes the raw material, it consumes the man hours, and it also uses the material, machine, and also it occupies this space. And if any problem is occurred, then we need to rework the whole lot. Or if the customer is not uh, pulling the material, if it is not lifting the material, then it is a problem. Then waiting for man, machine, or material. But priority should be material, machine, man. And then non-utilization of human talent means we are not using the human potential. We are not using our brains. We are using the hands of the employees, but we are not using the brains of the employees. And then transportation, unnecessary movement of products or materials. It is not unidirectional flow, zigzag, crisscross flow. Yesterday we saw that layout. Because material is traveling here and there is a no unidirectional flow. There's a zigzag or crisscross movement of the material. Then motion is always related to human. It may be a man or woman, and the transportation is related to goods. And motion is unnecessary or extra movement of people searching, walking, bending, etc. And because of that motion, it creates the fatigue. If it motion is excessive, it creates the fatigue and it may lead to an accident, or operator will not work as per the efficiency. Efficiency will be low, chances of accidents, and he will not able to produce quality product. Clear? Now, we would like to discuss about the inventory and extra processing. But before moving to the inventory, so can anyone tell me why inventory is treated as a waste? And is inventory is required or not? Because if inventory is not there, how we can produce? Inventory is essential. Inventory is needed. But why inventory is treated as a waste? Inventory is needed. It is essential. We cannot produce our parts. Excess inventory is a waste. Yes. Okay. Yes, definitely. Excess inventory is a waste. Inventory is a waste, but excess inventory. We should use the inventory, but optimum inventory. We should use the optimum inventory. The word is very, very important. Optimum. So optimum inventory is required. But if we are carrying the excess inventory, that is waste. Okay. Now let's discuss why inventory is needed. Why inventory is needed? Because if inventory is not there, there will be a stock out. So always remember that in lean, because there should not be a stock out. There is a stock out and hence we are not able to fulfill the customer delivery. That is very, very dangerous. So we need to carry inventory. Stock out should be avoided. Stock out should be avoided because we have a customer order and we should fulfill that order. We should avoid the stock out. So we need to carry the inventory. That is agreed. But the question is how much? Inventory is needed, but question is how much? And before discussing that, as I told you, why inventory is treated as a waste? What are the reasons? What do you think? Please tell me the reason. Yes. Tabish is saying that it occupies space. Correct. It occupies space. Cost. Yes. Arvind is saying that our money is blocked. Working capital. Yes. Aniket is saying that our working capital is blocked. Always remember that the owner's money is always very costly. The owner's money is always very costly because we are consuming the money from the owner's pocket. So first, reason why inventory should not be excess. The first reason is that it blocks the capital, and particularly it blocks the owner's capital. Suppose my MD's money is blocked in inventory. Yes. So that is one reason. Correct. Correct. So first reason is that our money is blocked. Yes. Second reason, yes, shelf life. Praveen correctly said shelf life. So shelf life. So that is the second reason inventory is treated as a waste, because every item has a shelf life, and if we carry excess inventory, that is a, then suppose there is a expiry date, and then it is a very, very risky, because everything has a shelf life, and it is a dangerous, that it is a risk that sometimes expiry will occur to that material, related to that material expiry date. For example, if very close, then our money will be wasted, our space is blocked, and our shelf life is important. Yes. And fourth reason is that, do we really need to carry an inventory? Let's take an example. Let's take an example, because normally, suppose we are consuming the tea. Particularly in my house, we are consuming the tea. So we purchase tea powder. For example, 1 kg of tea powder normally we require per month. Example. Okay. Now, before discussing about the why inventory is waste, so very simple question. Even though I can buy a 5 kgs of tea powder, or I can buy 3 kgs of tea powder, but normally I buy only 1 kg of tea powder. Even though I can buy 3 kgs of tea powder, I normally buy 1 kg of tea powder. And what are the reasons? Can anyone tell me what are the reasons why I'm not buying 5 kgs of tea powder? Okay. Huh. Yes. So may get expired. First reason is that my money will be blocked. Tea powder is costly, so my money will be blocked. That is the reason number one. Even though I have the capacity to buy 3 kgs, but my money will be blocked right now. That is not required. So that is reason number one. Reason number two is that quality get ruined. That is also correct, because it may affect the quality. Because if I purchase 3 kgs of material, tea powder, or coffee, for example, 1 kg of coffee, it is very costly. Uh, yes, even though I can buy, but it affects the quality. So second reason is that it affects the quality. If the expiry date, it affects the quality. So reason number two is it will affect the quality. It will affect the taste. First reason, money is blocked. And Ninad is correctly saying, suppose if I buy 5 kgs of tea powder, then I will more space is occupied. Suppose I have a container, so that can store 1 kg or 1.5 kgs of tea powder. But if I purchase 5 kgs of tea powder, then my space will be blocked. So more space is needed, more container size is needed. Yes. So hence, so I am not purchasing the 5 kgs of tea powder. So this is reason number third. First is money is blocked. Second is quality can be reduced or ruined. And third is that space required. And I need to purchase one container again, or it will consume more space. So these are three reasons, correct. So what is reason number four? These three reasons are genuine. The quality will be affected, more space will be required, and money will be blocked. What is the fourth reason? And that is important, because that is not my need. To be honest, that is not my need. So I am not living in forest. I am not living in forest. Anytime I can go, and there is very grocery shop near to my home. I can buy at any time. Suppose 200 grams in stock, I can go out and I can buy that. So I'm not living in forest. That is not my need at all. Why should I buy 5 kgs? Because grocery shop is very close to my home. So whenever there is a 200 gram stock, I can walk out and I can purchase the tea powder. So there are 4 reasons of that. First reason is that money will be blocked. Second, it will affect the quality, shelf life. Third is that more space is required. And fourth is absolutely not needed because I am not living in forest. I can easily buy out. Okay. And hence inventory is treated as a waste. And always remember, when we purchase inventory, it is money blocked from owner's pocket. So money is blocked from the owner's pocket, and owner's money is always expensive. Because suppose we want to purchase new machines or any new expansion of business, that money is needed. And if we are blocking that money in carrying the excess inventory, then the owner will not spare that money for the other reasons. So that is the reason. Clear? Now my next question to all of you is, can anyone tell me the forms of inventory? So it is said that inventory is visible in 3 forms, 3 to 4 forms. What is that form? What are those forms? Yes. Aniket ji is saying that raw material, work in process and finished good. Correct. Okay. Yes, yes, that is also fast moving, slow moving. These are types, but normally I am saying that form. Form means I can able to see the inventory in the form of raw material. In the form of raw material. For example, if I visit the stores department of my company, there are, suppose I was working in a die casting organization. So I saw the ingots, the metal, the raw material, the aluminum ingots, the bricks of aluminum, that is called as ingots, the bricks of aluminum. So that is raw material. I am going to use this raw material to produce castings. So the inventory in stores, that is called as raw material inventory. But it is called as raw material inventory. It is normally I can observe raw material inventory in stores department. When I visit my stores, so everywhere I saw the raw material. So that form is called as raw material form of inventory. Okay. Suppose now I go and I stand at my dispatch dock. Means our goods are packed, they are kept on pallet, boxes are kept on pallets that are wrapped, and it now ready to dispatch. We are ready to dispatch. As soon as container will come, we will load that material in the container. So that is called as finished good inventory. So that is second form. Means I am standing in dispatch dock, and what is the inventory in front of me? That is called as finished good inventory. The inventory in stores is called as raw material inventory. The inventory in dispatch area is called as finished good inventory. So now I'm going to dispatch this inventory, this finished good to the customer. I'm just waiting for the container, and customer, as soon as container I will load, and still some inventory will be there. That is called as finished good inventory. Means I need not to process that inventory. That is called as finished good inventory. I will directly dispatch this inventory to the customer. I will not carry out any single operation. I will not carry out any single operation. Inventory is finished good is actually available, and I need to just dispatch it. So I will not carry any operation on that inventory. So that is called as finished good inventory. So first form of inventory is called as raw material inventory. Second form is called as finished good inventory. And what is the third form? Third form is called as work in process inventory. Suppose if I just walk from my shop floor, from the operation number 1, suppose there are 20 operations, operation number 1 and operation number 20. And after operation number 20, it will become the finished good. All the inventory lying between operation number 1 to operation number 20, all the inventory lying between operation number 1 to operation number 20 is called as work in process inventory. Clear? So 3 forms are clear. Once again, I will repeat. The inventory which we will observe in stores, that will be treated as a raw material inventory. It is a raw material. And I am going to process that raw material, and I will convert that raw material into finished good. So that form is called as raw material inventory. Now I am standing in dispatch area. Everything is, all the operations are completed. parts packed in the boxes, it kept on pallets, pallets are also wrapped, and I'm just going to send this material to the customer. So that form of inventory in front of my eyes, that is called as finished good. No further operation will be carried out. That is called as finished good inventory. And third inventory is called as work in progress inventory or work in process inventory. What does it mean? The inventory lying between operation number 1 to operation number 20, that is called as work in process inventory. So understood these three forms? Please type yes if it understood. Okay. Okay. Now imagine that I have a tea stall. Suppose I have a tea stall. And then what could be the RM? What could be the work in process? And what could be the FG? Suppose I have a tea stall. So now I have given a task to you. Please identify the raw material inventory, work in process inventory, and finished good inventory. So what will be the raw material inventory? What will be the WIP? And what will be the finished good in a tea stall? So I am a owner of a tea stall. So, okay, raw material will be tea powder, not tea. Tea powder, milk, sugar, suppose tea masala is there, etc. So tea powder, milk, sugar, ginger, etc. That will be my raw material. Okay. Yes. What will be my finished good? What will be my finished good? Tea. Tea means processed tea. Now tea is FG is finished good tea. So suppose there is a thermos, big thermos, and I have stored 100 cups of tea in that thermos flask. So that is called as my finished good. So tea is ready. As soon as Aniketji will arrive at my stall, I will just serve the tea because tea is ready in that thermos. That is called as finished good. So as soon as Rakeshji or Aniketji will arrive, I will just serve the tea to Rakeshji or Aniketji. That is called as finished good. Okay. And what is work in progress? Suppose, yes. So now I am preparing the tea. There is a gas stove and I am boiling the tea. Suppose that milk, water, tea masala, tea powder, sugar is added in that and tea is boiling on gas stove. So when I click the photo of that, that is called as WIP. This is all. Yes. When I am preparing the tea on the gas stove. So now it is not a raw material because I have consumed that raw material and put in that vessel. And now it is not finished good because tea is just preparing. So I'm just preparing the boiling. So that is called as work in progress. Clear? Understood? So that are called as three forms of inventory. Raw material inventory, finished good inventory, and work in progress inventory. Okay. And I normally give the example of tea because as a lean practitioner, that is my favorite product. So that is my favorite product. I will tell you why. Because in lean manufacturing, it is always said that the finished good, as soon as finished good is prepared, it should be consumed by the customer. For example, currently I have prepared the finished good, but it will be consumed by the customer after 2 months. So I'm not telling that, but that is in lean, that finished good should not remain at my site. As soon as I prepare the finished good, it should leave my site. And tea is the best example because as soon as finished good is prepared, it is consumed. So normally my wife is preparing the tea, product is prepared, tea is prepared, it is strained in the cups and we are directly consuming the tea. Means as soon as product is finished good is prepared, it gets consumed. That is always an ideal situation. So normally I give the example of tea because as soon as, particularly in my home, as soon as FG gets created, customer is consuming it. That is a very good product. And hence normally I'm saying that tea is a best product as far as the lean is concerned, because as early as possible that FG should be get consumed by the customer and then customer should pay. We are not paying to our wife, but customer should pay. I have a tea stall. I am preparing the finished good. I stored that finished good in thermos plus and just I'm serving the customer and again I'm asking, please give me the 10 rupees for every cup. So one cup, again 10 rupees will be received like that. So immediately I can get that money. That money is credited to my account or customer can give me the money in physical form. So that is always a good example as far as the lean is concerned. Okay. So inventory forms are clear. And why excess inventory is waste, it is also clear. And hence inventory is treated as a waste, but always remember excess inventory will be treated as a waste. Excess, because inventory is required. If we don't have the inventory, we will not able to produce our production. Clear? So please type yes if it is clear. So forms of inventory and why excess inventory is treated as a waste. 4 reasons, right? Money is blocked, shelf life, space will be consumed, and it is not need at all. Okay. So we covered the 7 waste and one waste is remaining, that is called as excess processing. Excess processing. What does it mean? Can anyone tell me what is excess processing? Okay. Process paralysis. Okay. Yes, additional process which is not mandatory as per the standard. Correct. More than requirement. Whose requirement? Vibhuti, is it? Customer's requirement. I will give an example, simple example. Suppose this is a part. Suppose this is a part. I'm preparing or manufacturing one part. And suppose that surface finish of that part is X. For example, customer is mentioned that the surface finish should be like this. This is mentioned by the customer. And I have prepared that material. I have prepared the part accordingly because we need to prepare our parts, we need to manufacture our parts as per customer requirements. We need to take care of customer requirement. We saw this because customer is very, very important. And suppose that the finish expected by the customer is already produced. But suppose if anyone is saying that customer is God, customer is everything. So please, we should increase the surface finish. We should improve the surface finish further because customer will be satisfied. Customer will be delighted. Customer is expecting X, but we are trying to give more finish. It is on good side. Good side. And customer will be happy. Customer will be happy. There will be no customer complaint because customer will get improved surface finish. As an example, I am giving you. Now, even though customer is delighted, even though customer is satisfied because we are giving a better surface finish, customer is expecting X and we are giving better than X and customer will be definitely happy. Suppose customer will definitely delighted, but what that extra finish, if he is not giving us money, he is not willing to pay for that extra finish, then it is termed as excess processing. Excess processing means we are consuming the resources. We have already prepared a part. We have already manufactured a part as per the customer requirement. But in order to satisfy the customer, in order to delight customer, we are improving the surface finish. That is fine. But if customer is not willing to pay for it, then it is over processing. Customer will be happy, but if it is not going to pay for it. For example, if I have a restaurant, and customer came to my restaurant and he ordered suppose 4 plain rotis. He liked the butter rotis, but because of budget constraint, suppose he ordered 4 plain rotis because he can afford only plain rotis. So butter rotis will be costly, for example. So if that customer is arrived at my restaurant and if he ordered 4 or 10 plain rotis, and if I am giving them butter rotis, If he don't want the butter rotis, then customer will be not happy. But suppose he will happy because he wanted to purchase or he wanted to give order of butter roti, but because of high price, they ordered a plain rotis. And suppose I deliver them butter rotis. Now they will be happy because they were thinking butter roti. And if I delivering them butter rotis, even though they ordered a plain rotis, customer will be delighted. Customer will be happy definitely. But if they are not paying extra money for that, so they will say we ordered only plain rotis. You gave us butter rotis, but we will not pay extra for that. Then it is called as over processing. You are doing it over processing. Customer is not willing to pay, even though customer will be happy, but you are consuming the more resources and customer is not ready to pay for it. So that waste is called as extra processing, doing more work than required by the customer. Okay. Suppose there is a one Pani Puri Thela near to my home. And normally in India, when we order Pani Puri, we get masala puri. Correct? When we order a Pani Puri plate, we get a masala puri. Correct, na? In India, normally after Pani Puri, they give you masala puri. At least in Pune, I don't know about other states. But when we order Pani Puri, the coating of the Western. Okay. Yes, yes. Correct. So suppose they gave, normally if I order a Pani Puri, they give me a masala puri. Okay. Otherwise, now I am a Pani Puri wala. And you came to me and you ordered one plate of Pani Puri. So I give you one plate of Pani Puri and suppose you like the masala puri. Suppose you like the masala puri. So I give you one masala puri after Pani Puri. You will be happy. Not happy because it is expected, because you are normally expecting that. You will not be delighted because in India after Pani Puri, you normally we give one masala puri. Suppose I give second masala puri to Anikej. Arey, Honey gets like the masala puri. So one masala puri, it's okay because he is expecting. I'm giving second masala puri. Yes, he will be happy because I give two masala puris. Then again I can give third masala puri. So this is third masala puri. Then Aniketji will be delighted because received two extra masala puris. But if customer is saying that we will only pay 20 rupees, I am not going to pay you 22 or 25 rupees, then it is over processing. You did over processing. So customer was expecting only one masala puri. You are giving two masala puri. You are giving three masala puri, much more than the required. And for that, customer is not willing to pay. Customer will pay only 20 rupees. Then it is extra processing, or it is called as over processing. You are trying to please the customer, but customer is not willing to pay. And please remember, customer is expecting and we are giving that expectation. We are confirming to the specifications. We are fulfilling the customer requirements, but we are giving more, which is customer not required at all. Customer is happy with one masala puri, but again you are going to second, third masala puri and customer is not willing to pay for it. Then it is extra process. Correct? Yesterday, there is a laundry wala, so near to my home. So it was a dry cleaning. So I went to take my shirt. So while giving shirt to me, so that shirt fell down. So he was giving me a shirt, and that shirt fell down on the floor. And that shirt was pressed, very beautifully pressed. But now again the shirt fall on floor. So that shopkeeper is saying that, sir, please give back me that shirt. I will once again press for you because it is my mistake. It is fallen on floor because of me. So I will once again press and I will give it to you. And now he once again pressed my shirt. Will I give 8 rupees more? Even though I give 8 rupees, and while giving the shirt to me, that shirt was fallen on floor. Again, he's pressing that shirt. Will I give 8 rupees more to him? Because it is his mistake. It's not my mistake. His mistake. So I will not give money, right? I will not give money. Always remember, customer will not pay for extra processing. Always remember, customer will not pay for extra processing. Clear? So these are called as 7 plus 1 type of waste. Understood? Is my screen visible? And is it audible? Okay. Yes, yes, music. Now we will see one video. We will see one video, audible as well as visible, correct? So there is one video. So I request you. Yes, I have stopped that video. Now there is one simple process. There is one simple process, and that process is called as making a toast. So that guy is preparing a toast. Okay, it's a very simple process. Preparing toast. Okay, that is very simple process. Now you need to observe that process. You need to observe that process, and please find out the wastes. So we studied 7+1. So forget about that non-utilization of human talent right now. Original 7 waste, just Team Wood, because he has having the talent and hence he is making the toast, and he is making a toast for his wife. So that a person, he is making a toast for his wife. Now just to observe the very simple process. Process is making toast. Please observe the process and please let me know what are the wastes. So now we have trained on waste. Then our further task is we should able to identify waste. Always remember, we should able to identify wastes. We should able to identify wastes. Always remember. So sometimes people are, no, yes, conceptually they are clear. But when I tell them, please identify waste on the shop floor or Gemba, it seems difficult for them. So it is a very simple exercise and the process is making a toast. Now you need to observe this process, very simple process of making a toast. And then it is an exercise for you that please observe that process and find out the wastes which are visible. Clear? Understood? Okay. You need to observe that process and find the wastes. Okay. I will play that video once again.
The video that you're about to see has been created to demonstrate some of the basic philosophy and principles of the Toyota production system, or as we call it today, lean thinking, lean manufacturing, or lean administrative. The ideas apply equally to any segment of the business, but we take them into the kitchen to try to get them out of all of those areas so that people can watch without being encumbered by predispositions that they have about their current jobs. It is a go-see video in those areas so that people can watch without being encumbered by predispositions that they have about their current jobs. It is a go-see video where we ask people to watch and become engaged, which is also a critical part of being lean. So join us and enjoy. It's amazing what we can learn from our own intuition if we'll only watch and see what's going on in the process. Two of the most important points of what we call lean manufacturing involve direct observation of the process, and then once we understand what we see, effective use of countermeasures to remove the problems that we see, and in particular the use of what we call KAIZEN. KAIZEN is a Japanese word that means small.
Is it audible? Is it audible or? What is it? Okay, sufficient volume. Okay.
Change for the better. many small changes for the better, and in particular, it means small changes that are created from the intuition, experience, and common sense of the people who do the work. Too often, we overlook these opportunities, and as Mr. Ono and Mr. Shingo at the Toyota Motor Works discovered, almost 9/10 of the time between paying and getting paid in our business involves waste, which can be identified through direct observation if we will only watch. So today we have a process for everyone to watch. Every shop floor, of course, is different, and we need to choose a shop floor which is easy to bring to many people and one in which you all can provide some intuition because you have done the process yourself. So we pick a very simple process, and that process is making toast. Now, it is a simple process, but it does involve a machine, a toaster, tools, conveyance equipment, a plate. It involves a customer. In this case, it's my wife is the customer, and it involves a person who is doing the work, and that will be me. So I invite you to come to my shop floor where we can watch the process very carefully and watch with an eye for improvement to try to understand what can be made better in this process. Watch the video, and then we'll get your thinking before we continue with an improvement. Making some toast for my wife. Made you some toast.
Is it raisin toast?
Okay, so we will discuss now. So what are the wastes? What are the visible wastes in this? Yes, motion. Because every time he is going and he is buying the, sorry, not buying, he is taking the bread and toaster is at different locations. So there is a motion waste as well as we can say transportation because he is again taking the material as well as if it is related to material, it is called as transportation. If it is related to human, it is called as motion. It is both. So it is a motion as well as the transportation. Yes. So waiting is there, searching is there. Okay. Okay, that is also good. That is exactly somebody is saying customer requirement is not identified. In this case, he is the operator. In this case, he is the operator. He is the operator and he is preparing this toast, making the toast for his wife. But he is not asked his wife how many slices. So he uses 4 slices. Why he is using 4 slices? Can anyone tell me why 4 slices? Why 4 slices? Yes, capacity of a toaster. So in lean, we are saying that do not produce as per the capacity, do not produce as the resource availability. Raw material is available and toaster is having the capacity of 4 slices and he put the 4 slices, but he should ideally ask his wife. So we cannot say it is a overproduction or not, but we can definitely say he should ask his customer. Okay, so that is one. Second, motion was evident, transportation was evident, waiting was evident, and when he delivered the product to his wife, so he asked his wife, your toast is ready. So wife is asking, it is a raisin toast. A raisin toast means fruits. For example, the cherries like that on that slices. So that should be requirement of his wife, that raisin toast. So raisin toast means the, I think we should using the cherry even butter like that bread. So that is the problem. So it is a defect as well. It is a motion as well. It is a transportation as well. It is a waiting as well. And he is not discussing with his wife, with his customer. And there is a processing. Extra processing means that butter or that cheese is very difficult to cut. So if he can remove that butter or cheese, suppose 5 minutes back from the refrigerator, then it will be not a problem. So he just actually opened the refrigerator, took that cheese, and it is very difficult for him to cut. Okay, and he was struggling a lot. So all these are called as waste. So you identified motion, you identified the transportation waste, you identified the waiting waste. But my question to all of you is, waiting, I can understand waiting waste is there, but that waiting was required because that is a processing time, right? So there should be some time given to convert that bread to toast. And we cannot act on that because it is required. So if he can remove the bread early, then it will be not a toast. And if there is a delay, that toast will be the bird. So that time, for example, I don't know, it is 30 seconds, 32 seconds or 40 seconds, that is required at all. We cannot reduce that time right now because it is the requirement of process. For example, it is taking 40 seconds to convert that bread into toast. So we should give that time. But the question is, when that time was there, 40 seconds or 60 seconds, he was standing idle. Operator was standing idle. He can do the other work. Right now, he is not doing the other works. We are talking about that time is required. That is called as processing time. 40 seconds or 60 seconds to convert from bread to toast. That time is required. And currently, we are not talking about reducing that time. agreed that time is required. That is the process time right now, or cycle time, you can say that process time. But the question is, he was standing idle for 1 minute. So in that 1 minute, can he do the other activities instead of standing there? That is the question. Okay. So that can be a question. Can he do the other activities in that 1 minute? Secondly, can he reduce the motion waste? Can he reduce the transportation waste? What is your thought? So suppose if we want to reduce this waste, we need to attack this waste, and this is elapsed time. The time is 4 minutes and 12 seconds, means it is 252 seconds. This is called as 252 seconds time. So this time in lean manufacturing is called as lead time. Lead time means when customer places an order and when we deliver this product to the customer, that is called as lead time. For example, if I ordered mobile from the Amazon, suppose I placed the order at 8 p.m. today on 24th July and I receive the mobile on 26th July at 8 p.m., then lead time is 48 hours. When a customer places an order and when customer gets that product, that is called as lead time. So here that is lead time is 252 seconds. And in lean, we should always reduce this time. We should always reduce lead time. Always remember in lean, we are focusing on the reduction of lead time. So that 252 seconds time is required. That not required, that is lead time. So our aim we should reduce that lead time. That is always aim in lean. Okay. The question is how? The question is how? And the answer is we can reduce the lead time if we identify wastes and if we eliminate or reduce waste. So we should identify the wastes first, and then we should act on that waste. We should kill that waste. We should reduce that waste. That is expected in Kaizen or Lean. So we will work on reducing the lead time. How? By identifying and eliminating wastes. By identifying and eliminating wastes. Now, what could you do? Suppose you are a lean engineer or a Kaizen practitioner and you have very well trained in the 7+1 waste. Now I will give you a task to reduce this time from 4 minutes to 12 seconds. Please reduce that time. So what could you do in this case? I give you a task. Identify waste, you did it correctly. The next task is reduce this lead time. So what will you do in this case? So what are the Kaizen opportunities? Always remember that we should think about the Kaizen. We should use one tool against the waste, and that tool is called as Kaizen. So now I'm requesting you, please give me your suggestions how you can going to reduce this lead time. You can change the layout, etc., etc. Process is not expected to change right now. That will remain the same, but you can change the layout. So what will you do? Yes, Bhaskaran is saying that keep or place raw material near to the machine. Yes, shift oven. That is called as point of use storage. We discussed, right? POUS, point of use storage. And if we do that simple activity of point of use storage, then it automatically your time also will be reduced and fatigue also will be reduced. Okay. Secondly, what is expected? Who is customer in this case? His wife is customer, right? I will just stop the sharing and I will reshare. Yes, wife. So he should ask his wife, correct? Yes. Requirement. So he should get the requirement of the customer. He should ask which type of toast the customer is wanted, or what is the need of the customer. And then he can relocate the toaster. Okay. He did the same. He did the same. And now let's watch the after condition video.
Okay, I hope you enjoyed watching the before condition, and I'll bet since you were watching, now I don't even know what the customer wants.
You already said it.
Improvements. What type of toast would you like?
Wheat.
Okay. How many slices?
Just one, please.
Very good. Do it. All set.
Thanks, dear.
Now see what he did. As you told, he moved the toaster near to the raw material. So because of that, motion as well as transportation is reduced. That is number one. Number two, he asked his wife what type of toast she wants. So he actually voice of customer, he captured the voice of customer. Second, third, what he did, how many slices? So it should not be overproduction. So his wife said only one slice. So now he inserted only one slide in that toaster. And fourth improvement he did that he removed the butter much early from the refrigerator. And now it is very easy to apply that butter on the slice. And because of all these action and because of all these action, time reduced from 4 minutes 12 seconds. It was 252 seconds earlier. Now it is 137 seconds. So our aim should reduce the lead time in lean. And here lead time is reduced. How? Because he acted on the waste. So you need to identify waste first. Then you should act on waste. That is also important. We should able to identify the waste and we should act on that waste. We should capture the requirements of the customer and then this time is reduced. Clear? So understood this video? Very simple video. Okay. So lead time can be reduced if you want. Yes, please identify the waste and please act on the waste so that the lead time will be reduced. And always remember there is only one tool against the waste and that tool is called as KAIZEN. That tool is called as KAIZEN. Okay. Okay. Now, yes. So there are one question to all of you. I have purposely made this in blank. So we discussed about the West. We discussed about the West. But my question to all of you, West is a cause or West is a symptom? West is a cause or West is a symptom? Not cause, no cause, C-A-U-S-E. I'm talking about C-A-U-S-E, cause. It is a cause or a system. Oh, sorry, symptom. Waste is a cause or symptom? Yes, always remember waste is a symptom. Waste is not a cause. Waste is not a cause. The cause is different. Okay. So these are the causes of waste. So we are not going to discuss all the causes, but always remember causes are different, and these causes will lead to wastes. Okay. So we will discuss some of the causes. For example, my layout is not correct. Scattered layout, zigzag layout. It will lead to which type of waste? Cause is different. A cause is different. Waste is a symptom. If my layout is not correct, that is the cause. It lead to transport and motion. Yes, correct. Very good. Now, my maintenance practices are not good. Machine is always under a breakdown. It is not producing the correct parts sometimes. So it will lead to which type of waste? It will lead to waiting. And suppose if defects is can also lead to defect if my machine is not producing the required pressure which is needed. So it can lead to defect as well. Waiting is there because there is a breakdown and again waiting and defect as well. Okay. Now lack of training, lack of skill, each will lead to which type of waste? Defect, yes. Lack of training, I'm not utilizing employee, but it is training is lagging because they are producing part. Now they can produce that can lead to a defect. Yes. Okay. Ergonomics, poor ergonomics. Which type of waste it lead to? Ergonomics is poor. It will lead to motion. Very good. My supplier is not reliable. Is not reliable. It's always problematic. My supplier is problematic. Which type of waste? It will lead to which type of waste? Yes, waiting and sometimes defect as well because supplier is not reliable. He may not correct process. Yes, it will mostly reduce the waiting. Inventory may be, but defect is definitely waiting because he is not supplying the correct material and there are always a defective. Okay. Okay. So understood. Always remember wastes are symptoms and these are not the causes. So causes are different and these causes leads to the waste and we need to act on the causes. Here in toast video, when that operator changed the layout and because of change in layout, motion and transportation waste is reduced, right? So causes are different and you need to work on the causes, then your waste will be reduced. Understood? Okay. Now we are going to discuss two more concepts. So muda is clear. The word for the waste in Japanese is called as muda or muda. Pronunciation is muda. So that is called as muda. M-U-D-A, muda. Okay, muda is clear. Okay, now we will discuss about mura and muri. तेजस आवाज कमी कर थोड़ा तेजस. Okay, the next is called as mura and muri. So these are called as our enemies. So these are called as three MUs: muda, mura, and muri. Muda, Mura and Muri. So these are called as three evils. These are called as three evils, Muda, Mura and Muri. Muda means west. We already discussed downtime. So Muda is a west. We already discussed about the Muda. So now we will discuss about Mura and Muri. So what is Mura? What is Muri? Can anyone tell me what is Mura and what is Muri? Mura means west. What is Mura and what is Muri? Muri is overburden. Yes. What is Mura? Mura is called as inconsistency, or it is called as the variation, unequal loading. Yes. Unevenness. Unevenness. That is called as Mura. Okay. Now let's discuss. Suppose this is a simple example. Suppose this is a pizza making. So I am making a pizza, for example. Now let's discuss about Mura and Muri. Okay. Suppose first step is pizza base making, and suppose it requires 160 seconds. Suppose it requires 160 seconds. So this is my process number 1. It is a manual. Suppose it is manual process. So pizza making. So it takes 160 seconds to prepare pizza base making process. Okay. And after this process, this is the input and the output goes to this process. This is process number 2. So output of this process goes to the process number 2. Okay. As an input. Okay. The second process is apply the coating. We need to apply the coating on that pizza. Suppose it requires 100 seconds. Apply coating is 100 seconds. Earlier it was 160 seconds. Now it is 100 seconds. Okay. Now see what will happen. So this process is taking 160 seconds and here is 100 seconds. So there is unevenness. Cycle time is not balanced, and hence cycle time is not balanced. This operator will always under waiting. Waiting waste will be there because this process takes 160 seconds to complete that operation, and for each and every he's waiting for 60 seconds for each and every process. So he will wait for 60 seconds, again will wait for 60 seconds, again will wait for 60 seconds. That is called as unevenness. So load is not balanced, it is uneven. Okay. So called as Mura. So third is apply topping. So this is the third process. Okay. And we need to apply toppings manually, for example. Now this is 140 seconds, and suppose he has a standard VP in between, there will be some WIP because it's 160 seconds, he will be waiting, and suppose he is carries some standard inventory, then there will be some inventory in process. And if he is not carrying standard inventory, then he will also, here a lot of inventory will accumulate. Okay. So this is 140 seconds. Okay. But last step is 240 seconds. For example, baking of the pizza. Okay. Now see the cycle time variation, 160 second, 100 second, 140 second, 240 seconds. So this is like this. So load is uneven. Load is uneven. Load is not like this. Suppose the cycle time is like this. This is operation number 1. This is operation number 2. Like that. These are the bars. Suppose these are the bars like this. Then it is said that line is balanced and there is no Mura. Mura is no there. So there is no evenness because line is balanced. All the work contents are the same. If this is the case, then there is a no Mura. But if this is the case, then there is definitely a Mura. If this is the case, definitely a Mura. Mura means unevenness. And this is no Mura. This is no Mura because cycle times are balanced or the processing time is balanced. So Mura is clear. Mura means unevenness. Load is not balanced. So sometimes it is 160 second, 100, 140, 240 like that. It is varying. It is called unevenness. And if load is almost 150 seconds, second is 145 like that. I'm not saying exactly 150 will possible. Suppose 160 seconds, second is 155 second, third is 163 second, fourth is 164 seconds like that. So it is almost balanced, then there will be no Mura. But there is a lot of variation, then it is called as Mura. Mura means unevenness, and always remember, Mura leads to Mura. Mura leads to Mura. There is a waiting. There is a waiting. For example, here this operator is waiting because it's 160 seconds time. Mura always leads to Mura. Waiting or inventory. Mura leads to Mura. Mura leads to Mura. Okay. So understood Mura. Mura means unevenness. Mura means unevenness. My loads are not balanced. Unequal loading. The avoid Mura is line balancing. Line balancing. Okay. Okay. I will explain you what is Mura. Mura means unevenness. Mura means unevenness. Okay. I will once again explain. Okay. Is this clear? Cycle time of each process. Suppose these are 4 manual processes. Mura means unevenness. Unevenness means my load is not balanced. My load is not balanced. For example, this is roti making operation. Instead of pizza, suppose it is a roti making operation. So first operation is, for example, making the rounds of the flour. So we are using the raw material as atta and making the rounds, or consider pizza making. So it is a 160 second. First process is called as pizza base making. It is 160 second. It consuming 160 second to complete this pizza base baking. Okay. And after that, second operation is that person is applying coating on that pizza base making. Okay. And the cycle time is 100 seconds. So here is the variation. Here is the variation, means cycle times are not balanced. Cycle times are not balanced. Now here cycle time is 160 second. So what will happen? What will happen? So suppose these two operators started working. So this operator, this 100 seconds, should always wait, because this operator is taking 160 seconds. Suppose he gave one product to him, he will finish in 100 seconds, and again he will wait for the 60 second. Okay, again second part, he will again consume 160 seconds, he will finish that in 100 seconds. So he will wait because he is ready, he finished his task and he will be waiting. So this is called as unevenness. Load is not equally distributed. Load is not equally distributed, for example. Third is suppose apply topping. So it is taking 140 seconds. And suppose this is the baking, it taking 240 seconds. So these all processes, these all 4 processes are not balanced. Means their cycle times are different. Their processing times are different. So this is the overloaded and this is less loaded. So consider these are the 4 operators and your work content is different. Work content is different, it is uneven. Work content is uneven. And because of that unevenness, it will lead to muda. For example, here it will be waiting like that. And here, for example, it will be a lot of WIP, because after every 40 seconds, he will place one pizza here, one pizza here, one pizza here. There will be a lot of inventory. Okay. So that is called as unevenness. Mura means unevenness. Suppose 4 or 10 operators are working in a line and their cycle times are different. But these are drastically different. I am not saying that 160, 162, 158. So 160 to 100, 100 and then suppose 200, 200 and 300 seconds like that. Then it is called as Mura, unevenness. Means my load is not balanced. My work content is not balanced. That is called as Mura. It is unevenness. Unevenness. My work content is not balanced. That is called as Mura. Unevenness. Variation in work content. Understood? Yes, there are some different formulas. I am not going to cover that formula, but it is a formula how to calculate number of operators. There is a formula how to calculate number of operators. But always remember that Mura means unevenness, and the only solution to Mura is balanced line. The load should be balanced. The load should be balanced. I am again saying 160 second, 162, 158 or 155 like that. then it is no problem. But 160, 100, 200, 300, if load is like this, then it is called as Mura because their work content are not balanced. Their work content is uneven, and that is called as Mura. When you go to the Gemba, suppose there are 4 operations, and just observe that, you will come to know that this apply coating person will always be on waiting. He will just idle. And the pizza base baking person, he's always loaded because 240 seconds, he has no time. There is no time. Again, suppose a customer is out standing there and he ordering the pizza. He will be doing it manually 240 seconds, for example. It is uneven. And Muri means, always remember, overburden. Muri means overburden. Muri means overburden. Suppose if one operator is loaded, so I will just use, suppose this is called as unevenness. Mura is clear, unevenness, because 160, 240, 100, this is unevenness, that is called as Mura. And Muri means overburden. So this is overburden because he is only working 100 seconds. He is working for 240 seconds for one cycle. Again, for second cycle, he will work for 240 seconds. He will work for only 100 seconds. So this operator, this is overburden. This is called as overburden. Overburdens means there is lot of fatigue. Example, physically lot of fatigue is there and he is not having any time, spare time. He is always busy. That is called as overburden. That is called as Muri. Muri means overburden. Mura means unevenness. Loads are different. My work content is not matching. It is varying. That is called as Mura. And the person with having highest work content. And if that person is lot of fatigue, or for example, this person is bending 27 times. Not only cycle time we should consider, we should also consider his physical condition. Suppose he is relaxed and time is 240 seconds, then it is not overburden. It is not his overburden. Overburden means there is some problem regarding ergonomics. There is some problem regarding to fatigue. Lot of steps he need to climb like that. And because of that, his cycle time is high. He is doing a lot of work. He is climbing steps like that. Or he's bending, he's waiting there, he's searching there, not waiting, he's searching there, awkward position. And because of that, the cycle time is 240 seconds. Then it is called as overburden. And there is one golden rule. Do not overburden man and equipment. Do not overburden man and equipment. Do not overburden man and equipment. So this is a golden rule. Do not overburden man and equipment. So clear? You can ping me separately on WhatsApp or you can call me if it is not clear. But please remember, Mura means unevenness. If cycle times are uneven, that is called as Mura because load content is not equally distributed. And Muri means overburden. If operator in case is overburdened, he is fatigued, he is tired, continuously he is working on that. That is called as overburden. Okay. The line balancing is the option. Line balancing is the option, Aniketji, because line balancing, work content should be equal. Line balancing. Solution is line balancing, single piece flow. Cycle times, processing time should be equal. Processing time should be equal. So, for example, can we move some of the work content from here? In this process, it is not possible. But suppose there are 4 different persons are working. Can we give some of his work to this person like that? So it can be done. Suppose some of his work can be distributed to. In my earlier organization, what we do, suppose that one person, he's packing the job, he's putting the silica gel inside, he's putting one extra bag is there, he's applying the labels, etc. So some of the tasks, it is given to the earlier process. For example, putting the silica gel like that. So you can just study the process time and just discuss, is it possible that some of the load from this person can be distributed to another processes? That is one. Second is line balancing, means always work distribution should be same. So can we transfer some task from this person to this person, from this person to this person? That can be done. Okay. Clear? Muda, Muram, Muri. Muri means overburden. I'm again saying that. Muri means overburden. If your operator is fatigued, as I told you now, suppose that operator is working for 12 hours. Hmm? There is no fan. There is a hot summer. He is working and he is continuously working. He is continuously working. Okay. So we will discuss. Muri means, Sahul, overburden means operator is overloaded. Operator is overloaded. Operator is overloaded. He is fatigued. For example, if you tell me to conduct training, for 8 hours continuously without speaking, just imagine, I'm a trainer and I'm standing and I'm continuously conducting a training. There is no break at all. Then it is called as muri on trainer, overburden on trainer, because you are not allowing him to take a break. If he is not allowing him to sit, here I am continuously talking for 1.5 hours. For example, continuously talking for 5 hours. Suppose you are just listening, but I am explaining. I am using my throat continuously. So it is called as overburden. When there is some limit. So sometimes we are creating excess pressure on operator. That is called as overburden. Maybe, yes. Okay. Yes, Arvindji. So just remember, or you can ping me, Mura means unevenness if workload is not distributed. And Muri means overburden. Muri means overburden. Okay. Now let's take, suppose there are 4 drivers, and they are driving for say 6 hours in a day. But for particularly one driver, you are giving him 20 or 18 hours driving. So, when I was in USA for 2 months and when I came back, I will explain you the Muri. So driver was came from Pune to pick up me. Okay. Now, when I understood, actually when I landed on Mumbai airport and he was supposed to take me to Pune, then I observed that driver is feeling sleepy. So I just asked why you are feeling sleepy, because it is a risk for both of us. So why are you feeling sleepy? What is the problem? Then that driver told me that he was not able to speak, he was not able to sleep properly from last 2 days because his son is ill and he's suffering from temperature, and temperature is very high. And for last 2 nights, he is not sleeping very well. And today he came from Pune to Mumbai to actually to drop one passenger, and he's supposed to rest because he was continuously on duty. But that driver, another driver who was supposed to take me from Mumbai to Pune, and he didn't came. And again his owner told him that please take this passenger from Mumbai to Pune. So for 2 nights he was not slept well. He did 2 or 3 continuous duties, and again his owner is telling him to drop me from Mumbai to Pune. Now it is Muri for the driver because he already drove for almost 16 hours, and from last 2 nights he is not slept well. Again his owner is saying that please drop this passenger from Mumbai to Pune because that driver didn't came. That is Muri. Our truck drivers, particularly in India, suppose they are driving continuously, very fatigued, very tired, then it is called as Muri, overburden. Beyond the capacity of human being. Beyond the capacity of human being. Okay? Muri is clear? Okay. Okay? Okay, we have only 5 minutes. We will just see the difference between Kaizen and problem solving. I will cover these Kaizen principles tomorrow. But can anyone tell me the difference between Kaizen and problem solving? What is problem solving and what is Kaizen? We will discuss tomorrow as well. But what is the difference between Kaizen and problem solving? What is problem solving and what is Kaizen? We will discuss this topic and then we'll stop here. What is the difference between Kaizen and problem solving? Okay. This is very important because normally people don't know the difference between Kaizen and problem solving. So somebody was asking me the same question. What is the difference between Kaizen and problem solving? So what does it mean exactly? What is problem solving? What is Kaizen? Okay, I will explain you. I will explain you and we will stop here then. So what is problem solving? What is problem solving? Suppose this is my standard. Standard means this is my output. That output is decided by suppose industrial engineering department. And I have achieved this output in the past. For example, 300 pieces per hour I need to produce. And this standard is given by the our industrial engineering department and this is achievable, for example, and we achieved this standard in the past, for example. But since last 1 month or last 2 or 3 months, I am not achieving that output. 300 pieces per hour, that is the output. That is the standard, but I am not able to achieve that output because of X, Y, Z reasons. I don't know. So that is, there is always a gap. That is a standard, but there is always a gap and I am not able to achieve that standard. I am not able to achieve that standard. So what is problem solving? Problem solving is nothing else but to achieve standard by reducing the gap. To achieve standard by reducing the gap, I need to do the analysis. Why there is a gap? Why I am not able to achieve that standard? Earlier I was achieving that standard. 15 days back we were getting 300 pieces per hour. What happened in 15 days? My current performance, why there is a gap? What has happened? Something has happened related to machine, for example. What is that gap? What has happened? I need to find out the reasons. I need to find out the causes. You need to work on this gap. And then you need to provide a solution. And suppose if after implementing a solution, you are once again achieving your output. So that is called as problem solving. I repeat, problem solving means achieving the standard. Whatever is the standard, that standard it is achievable. I am assuming that it is achievable. The target is achievable, but because of XYZ reasons, currently I am not able to achieve those output. And if I work on that gap, I identify the causes and work on that problem as a team, and I resolve this problem. And because of that, again, I am achieving the standard. So that is called as problem solving. That is called as problem solving. Example, suppose I am earlier, suppose 3 months back, I was able to run continuously 5 kilometers without stopping. So I was able to run continuously for 5 kilometers without stopping. And suppose because of new job, because of late working hours, because of hectic lifestyle, my health is deteriorated. My health is deteriorated. I'm continuously late working. There are a lot of stress, fatigue, no exercise. My eating habits are changed, etc., etc. I'm consuming, for example, lot of coke, etc. I'm consuming. So, and my health is deteriorated. And now I'm not able to run the 5 kilometer. Earlier, 3 or 4 months back, I was able to run for the 5 kilometers without stopping. And even though I was not feeling tired, but now I'm not able to run up to 1 kilometer because of my health, because of my diet, because of my lifestyle, because of stress, etc., etc. And suppose I realize the importance of health, I corrected it. For example, so I reduced my weight, I changed my diet, I changed my habits. So I started to build on my mental health as well. And again, I am now running 5 kilometers without stop, which was I was doing 4 to 5 months back. But since last 4 months, I am facing it as a problem to run 5 kilometers without stopping. But now again, from this month, I'm again started to run 5 kilometers without stopping. I achieved my earlier standard, that is called as problem solving. Achieving my earlier standard, which was achievable, but because of XYZ reasons, I am not able to achieve that standard. But if I achieve that standard, that is called as problem solving. Clear? Achieving the standard, that is called as problem solving. Okay. And then what is Kaizen? Kaizen is improving the standard. In simple words, improving the standard is Kaizen. Improving the standard is Kaizen. Suppose we saw the ASTM principle, and suppose how can we increase the output from 300 to 320? Can I reduce the cycle time by 1 second like that? And because of that 1 second cycle time reduction, now my new standard is 320 or 310 pieces per hour. Because I did some improvement here. I reduced the cycle time by 1 second or 1.5 second without compromising safety and quality. And because of that, my output is increased 320 pieces per hour. So improving the standard is called as Kaizen. And to achieve the standard by reducing the gap is called as problem solving. Clear? Now the example of Kaizen. Earlier I was running 5 kilometers without stopping. Now I improved my health. I improved the fitness level. And again I am able to run 6 or 7 kilometers without stopping because of my improved health. I am improved my standard. That is Kaizen. Improving the standard, that is Kaizen. And back to standard called as problem solving. In simple words, back to standard, problem solving. Improving the standard, Kaizen. Clear? Okay. So we will discuss tomorrow on the Kaizen principle and some contents, types of Kaizen, etc. And we will also discuss this slide once again tomorrow. So thank you and good night. So see you tomorrow at 7:30 p.m. and tomorrow will be our last day. So we will going to finish this program tomorrow. Okay. So once again, thank you very much. I hope, and tomorrow we'll start with the recap. I hope you understood the difference between Kaizen and problem solving. No, there will be no test.